A warm welcome. This is Electric Energy Generation, Utilization and Conservation course with lecture 4.4 focusing on braking. So braking is a frequent one in electric drives in order to stop the motor within a reasonably short period of time. For example, a planer must quickly be stopped at the end of its stroke and sometimes may quickly be stopped at the end of its stroke, but sometimes it is necessary to stop the motor in order to prevent the accident. The essential of any good braking system should be reliable, it should be quick in action, the braking force must be a controllable one, and then there should be adequate means for dissipating the stored energy, that is the kinetic energy of the rotating parts. And in case of any fault in any part of the braking system, the whole system must be coming to instantaneous rest. Or if suppose what the condition to which when brakes are applied in such an requirement, if it is satisfying the braking system, then that braking system can be completely relied upon. There are various types of braking system like mechanical braking and electric braking. Mechanical braking, in this case, due to the friction process between the moving point and the brake shoe, the stored energy gets dissipated as heat in the brake shoe or brake lining, and this will be rubbing against the brake shoe or brake lining, which rubs against the brake drum, right? So this is how the mechanical braking is done. While considering the electrical braking, there are various types like plugging, rheostatic braking and the regenerative braking. Let us see one by one, but let me explain the process of electric braking first. In this type of braking, the kinetic energy of the moving parts will be getting converted into electrical energy. It means the motor of the kinetic energy is nothing but the mechanical energy of the motor will be converted into electrical energy, and this is consumed by the resistance. As soon as the electricity is passed over the resistance, we know by I square R losses the heat gets generated, and this is in turn returned to the supply source. During the braking operation, a motor will be designed as to function as a generator. The motor can be held at standstill. Otherwise, the electric braking cannot hold the motor at rest. Thus, it becomes essential to provide any mechanical brakes in addition to the electrical braking. Then we can see how it is working on. That is the plugging process. It is a simple method of electric braking where it consists in reversing the connections of the armature of motor so as to reverse its direction of rotation. Obviously, this will oppose the original direction of rotation of the motor, and normally the speed will be getting reduced and it will reach the zero speed when the mechanical brakes are being applied. At the end of braking period, the supply to the motor will be automatically coming to off position. This method of braking can be applied for DC motors or induction motors or synchronous motors. For all these motors, plugging method can be applied. Next is the rheostatic braking. In rheostatic braking, we can see two different types of connections. One is the equalizer connection and the other one is the cross connection. Here we can see the armature and the field winding. Hence, we can see the armature and then second armature are connected in parallel, as well as the field windings are connected in parallel. In such a case, this rheostatic braking will be depending purely upon variation of the resistance value. So when resistance is varied, automatically the heat generated may get varied, and this will reduce the current flow through the circuit, and automatically the braking or reduction in the speed occurs. When current gets reduced, automatically the speed also gets reduced, and finally it will reach the zero speed. This is purely for the variation of the rheostat will be considered in this case. If it is a cross connection, we will connect the field 1 along with second armature and field 2 with the first armature. In this connection, the application of the rheostatic braking will be more effective when compared to the equalizer connection, since the field of the first motor is connected to the second armature and the field of the second field of second motor is connected to the first armature. Next is the regenerative braking. In case of regenerative braking, the only thing is the motor will be acting as a generator in such a case that during the braking process, the electricity will be supplied in the reverse condition. I mean, the electricity has to be generated at that case. We can see here we have a trolley wire here. The field windings are being connected and the armatures are connected, and this is how the motoring action will be taking place. The mechanical movement of the traction, the mechanical movement of the tractions will be here we will be supplying the electricity to the traction, and that will be mechanical movement. If suppose we are applying a brake, then when braking system is applied, the speed will be getting reduced. When this speed is getting reduced, normally the motor, in this case, in the case of regenerative braking, the motor will be converted into a generator. That is, it starts generating electricity with the movement of the rail track, the track I'm sorry movement of the traction will be taken as an input to it, and it will be generating the electricity, and this supply is then passed over to the system so that it forces the braking system to stop immediately.